Welcome to the dam site of the Bajoli-Holi hydroelectric project. The dam is situated across the Ravi river near village Bajoli in Himachal Pradesh. Here we can see the terrain and location of the dam. Let us take you through the process of constructing the dam. Before the construction begins, the river flow needs to be diverted to make excavation and construction activities possible at the dam location. This is done by diverting the river water through a diversion tunnel that bypasses the dam location. Excavation inside the diversion tunnel is carried out by drill blasting using a 2-boom hydraulic drill. The excavated material is stored near either end of the tunnel. The diversion tunnel is excavated from both the upstream as well as the downstream ends, gradually progressing towards each other. Simultaneous to river diversion, excavation for dam abutment, both in soil and rock, is taken up. Excavation is carried out with a small excavator and 1-boom hydraulic drill. The abutment slopes are excavated in stages until the river water level is reached. The excavated material is stored on either bank for further use in coffer dam construction. The excavated slopes are stabilized by installing rock anchors and spraying shotcrete. Upstream and downstream closure dikes are constructed using the excavated material by the end-on method. Dikes divert the river flow through the diversion tunnel at upstream and prevent the downstream water going back to the dam site. Upstream and downstream coffer dams are then constructed using the material excavated from the abutment slopes and the diversion tunnel. Water between the coffer dams is pumped out to expose the river bed. Further excavation is now carried out up to the dam foundation level. Simultaneously, tower cranes, batching plant, wet belts and other construction facilities are erected at appropriate locations. Let us now understand in detail the trajectory of material movement involved in the process of building the dam structure. Dumper trucks travel via an approach road to the aggregate silos and dump the crushed aggregates in the respective silos. A conveyor carries aggregates from the silos, one size of aggregates at a time, to the rotary feeder. The rotary feeder mechanism directs the aggregates flow to the respective conveyors and subsequently to the hoppers in the wet belt system. Here on, all the facilities are covered and insulated to avoid heat loss. The conveyors carrying aggregates of size 10 mm and sand pass through a chilled air blast, while larger aggregates pass through wet belts with chilled water spray with temperature of 2 degrees centigrade. To allow the extended time of travel for the aggregates in the wet belt, the conveyors move at a much lower speed. The temperature inside the wet belts is maintained at 4 degrees centigrade. Water from the cooled aggregates is removed by passing it through the dewatering rotating screen at the other end of the wet belt. Aggregates thus cooled are then carried via a closed conveyor and stored in pre-cooled storage bins. A strike plate mechanism installed over the conveyor directs the aggregates to fall in appropriate storage bins. Aggregates from pre-cooled storage bins are now carried via a closed conveyor to the batching plant weighing mechanism and further for mixing. At the batching plant, aggregates are mixed with cement coming from the cement silos and chilled water in the required proportions to make a concrete mix of the desired consistency. The concrete thus made is transferred into the concrete bucket placed on a truck that carries it to the dam location. The crane keeps down an empty bucket, picks up the loaded one and delivers the concrete to the desired location of the concrete fill that is demarcated by steel shuttering. A concrete vibrator is used to ensure that the pour is even and free of air bubbles. Concrete is placed in layers of about 300 mm thickness along the block width in a 3-meter layer at a time so that cold joints during placement are avoided. With slabs spanning the width of the dam, the entire structure is eventually built. Temporary structures like dikes and cofferdams at upstream get submerged underwater, while the downstream structures are removed after completion of the structure. What we see now is the completed dam.
The bow, violin, and the mechanical fingers are moved by electromagnetic actuators controlled by a complex computer program. The input to this program is a MIDI music file which I generate by playing my electronic keyboard. The program takes the note data, converts it into voltages that control the actuators, making the violin play whatever notes I had played. Let me just take a minute or two to show you the various parts. The bow carriage is attached to the black tooth belt. The motor turns the pulley and that moves the belt and therefore the bow carriage. It has an electromagnetic actuator which moves the bow up and down. The black device attached to the pulley shaft generates a voltage used by the computer to reverse bow direction. And this actuator determines which string is bowed by moving a very light metal cradle to which the violin is clamped. The carriage holding the four fingers usually is stationary. Its motion is confined to playing high notes on the top string. The fourth finger reduces the maximum carriage motion needed for very high notes. Here is the front panel of the computer program. Behind the scenes you can see some of the logic of this graphical computer language with its bewildering array of nested complexity. I'll play you an Irish jig to show you other types of music.
product, the Green Box. The pizza box of the 21st century, released on U.S. Patent 7051919, manufactured from 100% recycled and recyclable corrugated cardboard. The top of the Green Box tears along 2 perforations and creates 4 serving plates. The bottom of the box breaks down into a convenient storage container, which is handy for leftover pizza and easy to recycle due to its compact size. The storage container fits conveniently into any size refrigerator. Eco-incorporated in the Green Box, saving the environment 1 pizza box at a time.
Circuits are the building blocks of our modern world. They light our houses, and they're in our cars, computers, and cell phones. But building simple circuits still looks like this, or like this. We thought that we could do better. We wanted to make building circuits as simple as doodling on a piece of paper. No breadboards and no wiring required.
So we invented Circuit Scribe, the world's first ballpoint pen that draws electric circuits instantly. Hi, I'm Brett Walker, the co-founder and CEO of Electronics Incorporated.
Hi, I'm Annalisa Russo, and I'm the Director of STEM Outreach for Electronics.
We're part of Jennifer Lewis's research lab at the University of Illinois, and we've invented a water-based, non-toxic, conductive ink that writes on flexible substrates like paper. You don't have to shake or squeeze the pen, and the ink dries instantly, so you don't have to wait 24 hours for a functioning circuit. Circuit Scribe allows you to create low-cost, high-quality electronics instantly. We've also developed a variety of magnetic components that snap right into your circuits. No gluing, no soldering, just plug and play.
This technology has the potential to revolutionize the way circuits are taught in schools. It takes circuits out of the textbook and into the imagination. Circuit Scribe is about learning through creating. You can create simple circuits using nothing but paper and a small battery for STEM education projects, or for some very dynamic refrigerator art. The possibilities of Circuit Scribe really are limitless. Schematic sketches can become instant working prototypes. Circuit Scribe also interfaces with the Arduino Makey for DIY life hacks. We're really excited to get Circuit Scribe into your hands and see what you come up with.
We have the prototype completed, and now we want to get Circuit Scribe out to consumers. We found a company that will help us design and manufacture the first batch of pens, but we need your help to fill that order. If we pass our goal, we can develop more products, like resistor and insulator pins, and get Circuit Scribe into stores and classrooms.
We put together some awesome rewards packages for our backers, so pick up a kit and back Circuit Scribe. Thanks for your support, and thanks for watching.